let's look at this problem. Let f is from R to R be a differentiable function such that f of x equal to x square plus integral 0 to x e power minus t f of x minus t dt. Then find the value of integral 0 to 1 f of x dx. So let's say first we have to find f of x, right? So f of x is equal to x square plus integral 0 to x e power minus t f of x minus t dt. So if I want to simplify this, see here the variable is t, but we have x also here. So in order to eliminate this x, so first what we do is we'll apply the property. So the property will apply is integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So this property will apply now. So f of x is equal to x square plus integral 0 to x. So a plus b is x, right? So here variable is t. So we are replacing t by x minus t. So f of x minus t dt. So x square plus integral 0 to x. This is e power minus x into e power t into f of t dt. So we can bring e power minus x out because this is t, this is x, so both are independent. So 0 to x e power t f of t dt. So now this is f of x is equal to x square plus e power minus x into integral 0 to x e power t f of t dt. So we can multiply by e power x. So if I multiply by e power x f of x is equal to e power x into x square plus e power x into e power minus x. So 0 to x e power t f of t dt. So e power x into e power minus x will be 1. So e power x f of x is equal to e power x square plus integral 0 to x e power t f of t dt. So now I want to differentiate this. So if I differentiate it, so e power x f of x plus e power x f dash x, because uv, right? So first f of x into d by dx of e power x is e power x. So e power x into d by dx of x is f dash x. So this is e power x into x square is 2x, again x square into e power x plus this is d by dx of x into e power x f of x minus d by dx of 0 e power 0 f of 0. So e power x f of x plus e power x f dash x is equal to e power x into 2x plus x square e power x plus e power x f of x. So because d by dx of 0 is 0, so e power x f of x, e power f of x we can cancel on both sides. So e power x f dash x is equal to e power x 2x plus e power x into x square. So we can cancel e power x also. So f dash x is equal to 2x plus x square. So with this we can determine f of x, right? So f of x is equal to integral of f dash x dx 0 to x. So integral 0 to x f dash x is 2x plus x square, so dx. So this is 2 into x square by 2 0 to x plus x cube by 3 0 to x. So it will be x cube by 3 plus x square. So this is f of x. So even here what we can say is this is f of x minus f of 0. So for f of 0, put x equal to 0 in the given equation, put x equal to 0. So f of 0 is equal to 0 plus integral 0 to 0 e power minus t f of 0 minus t dt. We have put x equal to 0 directly. So integral 0 to 0 is also 0. So f of 0 is equal to 0. So f of 0 equal to 0. So that's why we are not writing here, or else f of x minus f of 0 we have to write. So f of x minus f of 0 is equal to x cube by 3 plus x square. As f of 0 is 0, we will get f of x equal to x cube by 3 plus x square. So integral 0 to 1 f of x dx is equal to integral 0 to 1 f of x is x square plus x cube by 3, so dx. So if I integrate it, it will be x cube by 3 plus 1 by 3 into x power 4 by 4, 0 to 1. So upper limit minus lower limit, right? So 1 by 3 plus 1 by 12 minus 0 by 3 plus 0 by 12. So this is, so 12 is LCM, so 4 plus 1 minus 0. So the value of integral 0 to 1 f of x dx is 5 by 12.